Guys, I was going through the 2018 past question for the quantitative method and I came across this question. I said, let us solve together and let's see what it's out to. So when I was going through the question, I realized that this question is coming from differentiation. That's where it's coming from. And it's from the part where you're going to know the first derivative and the second derivative, and also getting to know the constraint and unconstrained, where the Lagrange is being introduced. The Lagrange multiplier is being introduced. So oh, it's very interesting. So I want us to solve it together. So I want to take the question and then we solve the possible question that was given. So I'm reading. So suppose you are running a factory producing bottle of pure water that required water, which is W, as raw material. Your costs are predominantly human labor, which is H, which is two Ghana cedis per hour for your workers, and the water itself, which runs for 1 Ghana cedis per barrel. Suppose your production is loosely modeled by the following equation. So the production equation is Q is equal to 40W minus W squared plus 2WH plus 20H minus H squared, where Q represents the number of bottles of water, H represents hours of labor, and W represents barrels of water. So A is saying that if your budget is fixed at 202 Ghana cedis, calculate the maximum number bottles of water that can be produced and the level of water barrels and labor hours required to achieve these targets. And the B is saying that if your budget improves by 1 Ghana cedi, what will be the effect on the maximum level of production? So guys, this is a question. So I want us to dive into it. We shouldn't waste much time on this. Yes, it's going to be very interesting and amazing. So first of all, I said earlier that this question is actually coming from the topic differentiation, where you will see the first and the second derivative, and also getting to know about the constraint and unconstrained. So this actually is constrained question. It's a constrained question. And the reason why it's a constrained question, because of the A, they're saying that they have given you a fixed budget. They have given you a fixed budget, which is 202 Ghana cedis. So that's the amount that you are using to produce the pure water. So this is a point where you have gotten to a restaurant, you have gone to a restaurant, and when you got there, they said whatever that you are going to spend there is supposed to be up to 202 Ghana cedis. 202 Ghana cedis. So it means that you can't spend more than 202 Ghana cedis. No. So all the food, everything that you are going to pick there, if you pick only one thing and that thing is 202, it means you are done. So this is how it actually works. So you being limited to a certain amount of money, or maybe a food or anything. That's the constraint. Okay, so first of all, let's get a solution. So solution A. So for us to get our maximum number of bottles of the water, and also the water barrels and labor hours, first of all, we have to be able to get our budget constraint. our budget constraint. So them giving us 202 Ghana cedis, that we should use this one to produce the pure water or the bottled water. They said that for every per barrel, every water per barrel is 1 Ghana cedis, and per hour for the labor, for the human labor, is 2 Ghana cedis. So for us to get our budget constraint, so let me write budget constraint. In the budget constraint, it means that if we are producing 1 Ghana cedi of W plus 2 Ghana cedis of H, we are supposed to get 202 Ghana cedis. So this is how it's going to look like. 1 of W plus 2 of H supposed to give us 202 Ghana cedi. So this becomes our budget constraint. This becomes our budget constraint. So 1 per barrel of water and 2 hours per human labor is supposed to give us 202. That is when we will get to know the number of barrels and the H that we are going to use, then the hours that we are going to use. So when you get this one, for you to get the Lagrange multiplier, which is, this is how the symbol looks like. H W, so let me use small w, plus 2H minus 202. So this becomes our Lagrange multiplier. This becomes our Lagrange multiplier. But the budget constraint is a 1W plus 2H is equal to 202. But for us to get the Lagrange multiplier, this is how it's supposed to be. We have to move whatever that is here to the left side of the equal sign. So now this is our Lagrange multiplier. This is our Lagrange multiplier. So for us to get our Lagrange multiplier equation, or the total of the equation, we have to get this. So L, which is the Lagrange. So we have W, H, and this, which is equal to the whole equation, 40W minus W squared plus 2WH plus 20H minus H squared minus the Lagrange multiplier, which has W plus 2H minus 202. So now this is our new equation, the Lagrange. It is our new equation. So if we have this one, what we are going to do next is we have to find the first derivative of all the variables in there. So we have to find the first derivative of W, H, and the Lagrange multiplier. So this is how we are going to find the first derivative. So finding the first derivative so the first derivative of the Lagrange in respect is paired to W H in the multiplier. So finding for the first order condition, we have the L over, so we are going to do with H first. So this one we are going to calculate for the items here that contains W, the items here that contains W. So all the items here that do not contain W, we see them as a constant, or we work on them as a constant. And the first order condition for every constant is 0, or the y, the x of every constant is what is 0. So if there is an item here that is not attached with 0, we treat all those items as what? As a constant, and which definitely tends to 0. So if we are having 40W, we are going to have 40 because the W has a power of 1. And it's having a power of 1. The 1 is going to multiply the 40, which will give us 40. And the power that is 1 here, we are going to subtract 1 from it. That will tend to 0. And every object raised to the power 0, it means it's the number 1. So 1 multiplied by the 40 will still give us 40. That is why the W is going away. And also, we have W squared. So W squared, the 2 is actually going to, the power of the W is going to multiply the coefficient of W, which is -1, which will give us -2. And we are going to take 1 from the power of W, which is 2. So 2 minus 1 is going to give us 1, which remains 1W. And we continue. We have 2WH. 2WH. We still have W here, so we don't classify this as constant. So the W here has a power of 1. So when we multiply the 1 by the coefficient, it will give us 2. And since W has a power of 1, when you subtract 1 from it, it's going to be 0. So when it becomes 0, we treat it as 1, because every object raised to the power 0, or every number raised to the power 0 is 1. So 1. So W is going to tend to 1. So if 1 is multiplying the 2, it will still give us what? 2. And it still remains what with the H. Then we attach the H to it. Here we have 20H. And I said earlier that any number without the W that we are finding, or W that we are finding the first derivative of it, automatically becomes constant, which the y, the x of a constant is what? Is 0. So we treat it as 0. The same applies to the H square. And when it comes to the Lagrange multiplier, we have W in here. We have W in here. So the W automatically turns into 1. So 1 multiplied by the Lagrange multiplier becomes what? The multiplier. And here too we have 2H, and it doesn't include W to it, so automatically it becomes a constant, and we treat it as 0. And -202 also is a constant, and we treat it as 0. So now we are going to have our first equation for the first order condition, which is 40 minus 2W plus 2H minus the Lagrange multiplier. So we are going to do the same for H. The first order condition, and H is equal to. So the same applies. We are going to use the same knowledge. So any item here that does not include H, we treat them as what? As constants. So 40W will become constant, which we treat as 0, and W squared the same too. So here we have 2WH. So 2WH, the H here has a power of 1. So the power 1 here is going to multiply the 2W, which will give us 2W. And the power here is 1, and we are going to subtract 1 from the 1, which will give us 0. And every number raised to the power 0 is 1. So it means that the H is going to be disappeared. And we have minus H squared. Minus H squared, we are going to multiply the power by the coefficient of H, which the coefficient of H has is 1. So 2 multiplying 1 will give us what? Will give us 2. And since H has a power of 1, we are going to subtract 1 from the 2, which will give us 1. So which H still remains to be 1. And when we check we have 20H. Sorry, we have 20H here. So 20H being here, the power of H is 1. So 1 multiplied by the 20 will give us 20. And H has a power of has a power of 1. So we are going to subtract 1 from this 1 is going to give us 0. Every number raised to the power 0 is 1. So the 1 multiplied by the 20 will still give us 20. So when we come to the multiplier, we realize that we have W here, we treat it as constant because H is not part, which becomes 0, plus, and we have 2H, and 2H, we are still going to apply the same rule. Since H has a power of 1, the 1 is going to multiply this 2. But don't forget that the multiplier is attached to this 2H. So 1 minus the 1 will give us 0, which means that the H is going away. So the 2 multiplying the multiplier will give us minus 2, the multiplier. And we are going to do the same for the multiplier, which we are going to have over, which is equal to. So whatever that is here, we are going to treat them as constant because there is no multiplier attached to it. So whatever that is here is going to be what? It's going to be 0. And it's going to be left with the multiplier, which is W plus 2H minus 202. So we are going to have W plus 2H minus 202. Okay, so we have these 3 equations that when we differentiated in the first order condition. These are the equations that we had. And this means that every equation that is here is at its is at its resting point. Resting point. That is how we treat it. So every equation here is going to be what? Equated to 0. Equated to 0 because they haven't moved, they haven't done anything. So every equation here is at its resting stage. And the resting stage means that it is equal to what? 0. It is equal to 0. So we are going to equate all the equation here. So this one is going to tend to be 40 minus 2W plus 2H minus the multiplier is equal to 0. The same applies to this one. 2W minus 2H plus 20 minus 2 multiplier. The same applies to this one plus plus 2h minus 202 is equal to 0. Let me make 0 for this one. So now we have gotten three equations. And we having these three equations, we can rewrite them and arrange them properly. So we can decide to make some of the variables the subjects, depending on how comfortable you are. So at this point, we are going to make the multiplier the subject in here. So then we name them according to equation 1, equation 2, and equation 3. So we are going to have multiplier is equal to 40 minus 2w plus 2h. That is how it's going to be, which is equation 1. And at this point, we are going to have 2, the multiplier is equal to 2w minus 2h plus 20. This is equation 2. And we will make this one to w the subject, which is w is equal to 202 minus 2h. So now this are our three equations. So the moment that you do it like this, it's very simple. And we can see that the equation 1 and equation 2 can be solved. It can be solved by using substitution method. So we can put equation 1 into equation 2. So putting equation 1 into equation 2. And this is how it's going to be. So it's 2 multiplying 40 minus 2w plus 2h is equal to 2w minus 2h plus 20. So now this is what you are going to get. So the moment that you get this one, we solve it mathematically. So we are going to have 80 minus 4w plus 4h is equal to 2w minus 2h plus 20. So we can group like terms. By making the variables come to one side and the ones without variable also go to one side. So we are going to have minus 4w plus 4h minus 2w plus 2h is equal to 20 minus 80. 20 minus 80. So I think let's use the back here. So we had minus 4w plus 4h minus 2w plus 2h is equal to 20 minus 80. So this is what we had in there. So I've rewrite it here. So we will have negative 6w plus 6h, which is equal to minus 60. And at this point, we can divide through by negative 6. by -6. So this one is actually going to give us W minus H is equal to 10. This is what you are going to have. This is what you are going to have. So at this point, we can make 1 the subject. So I think let's make W the subject here. So W will be equal to 10 plus H, which give us equation 4. Which will give us equation 4. Okay. So let's go back and check our equations if we can put the value of W here inside, or the equation 4 inside any equation again. So we realize that, okay, equation 3, we made W to the subjects, which gave us equation 3. So we can put equation 4 inside equation 3. We can put equation 4 inside equation 3. So putting equation 4 into equation 3. So we are going to have 10 plus H is equal to 202, 202, 202 minus H, minus 2H. Okay, this is what you are going to have. This is what you are going to have. So we are going to have something like this. H plus 2H is equal to 202 minus 10. Let's the calculator. So we are going to have 3H is equal to 202 minus 10 will give us 192. 192. 192. So we can divide both sides by 3. H will be equal to, so 192 divided by 3 is going to give us 64. 64. 64. 64. So now our value for H is 64. And we getting H makes the thing even easier. We can easily get W because we have equation 4 here, which says that W is equal to 10 plus H. So putting the value of H into equation 4. So equation 4 is W is equal to 10 plus H, where H is equal to 64. So W is equal to 10 plus 64, which gives us 74. 74. Therefore, so let's check. Let's check how we are going to write it. Therefore, we said we should find for the level of water barrel and labor hours. Okay. So we can say that they can produce 74 water barrels using 64 hours. And the maximum production is going to be is Q. So Q is what? 40 W minus W squared. W squared. Let me see. The plus 2WH plus 20 H minus H squared. That is Q. That is Q. So there's it. So we are going to put the value of W and H inside the equation, which will give us our maximum production. So Q is equal to, so where H is equal to 64 and W is equal to 74. 40 multiplying W, which is 74, minus 74 squared plus 2 multiplying 74 and 64 plus 20 multiplying 64 minus 64 squared. So this is what you are going to do to get your maximum production, which is Q. So Q is equal to, there's a calculator, does it work here? 40 multiplied by 74, we are getting 2960 minus 74 squared. We are getting 5476 plus 74 multiplied by 64 multiplied by 2 will give us 9472 plus 20 multiplied by 64. We are getting 1280 minus 64 squared. Also getting 4096. So let's combine this one. We're going to put them on the calculator together. 2960 minus 5476 plus 9472 plus 1280 minus 4096. And we are getting 4140. So our Q is equal to 4140. So therefore, I'm going to write the maximum production, so let me see, the maximum number of bottles, the maximum number of bottles produced is 4140. Done. So let's get into the B. The B is saying that if your budget improves by 1 Ghana cedi, what will be the effect on the maximum level of production? So this one is very simple, very cheap, and it is very easy. So when we check the equations that we had the multiplier to have an equation 40 minus 2AW plus 2H. So let's be. For us to get the effect, or for us to see when our budget improves by 1 Ghana cedi, the effect that is going to happen, this is how we are going to do. We are going back to the equation that we calculated. As I said earlier, the multiplier was having equation 40 minus 2W plus 2H. So we are going to put the value of H and W. So what you are going to get will be the effect whenever that our budget improves 1 Ghana cedi. When the budget improves 1 Ghana cedi, that will be the effect. So when we put 40 minus where W is equal to 74 and H is equal to 64. So 2 multiplied by W 74 plus 2 multiplied by 64. 40 minus 2 multiplied by 74 is giving us 148 plus 2 multiplied by 64. We are getting 128 is equal to 128 plus 40. We are getting 168 minus 148, which gives us 20. So therefore, when the budgets improves, there is 20 so let me say there is a 20 increase. There's 20 increase in the number of bottles produced. And the reason why we are using the multiplier is that the multiplier or the budget constraint, this is the change that happens. So when you go back, this is the change that happens. So if this one changes, if there is a change, this is what happened. If it increases by 20. If it decreases by what? By 20. So whenever that there is one Ghana cedi improvement in our budget, there is 20 increase or decrease number of our bottle of water produced. Bottle water produce. So that's all about the B. So this is how you will get the effect. So if there is 1 Ghana cedi improvement, this is what happens. And this is what happens here. So I think this brings us to the end of the question B and the question A. So please, if maybe you watch this video and you don't get some things, you can write it inside the comments and I'll address it. And please don't forget to subscribe, and also don't forget to adapt to what I'm doing. Maybe if there is something that I don't actually make it clear, you can just let me be aware. Don't just criticize and without giving solution. And you get it. When you complain, you give a solution. How best we can improve because we are all learning. So thank you for watching. Please don't forget to subscribe and like. Thank you.